Hello, my name is Brian Locke and I'm a maker from Ireland. In a previous video we took a look at connecting to APIs using an ESP8266, but we never really finished those steps off. We connected to the API and we got the response back, but we just printed that response to the serial monitor, and that's not really good enough if you want to use the response for something in your project, for example displaying something on a screen. So what the next step is would be to parse that data, which is normally JSON. And to do that, we're going to use the ArduinoJSON library. The ArduinoJSON library is a fantastic piece of software. It's got really good documentation, and the author has even created a tool that really helps when we're doing the projects with ArduinoJSON, which we'll talk about in a moment. In fact, I don't think ArduinoJSON gets the credit it deserves. It's a fundamental building block of a huge amount of IoT projects on the ESP8266 and ESP32. I used ArduinoJSON for basically all my projects where an API was responding with JSON, other than one particular use case, where the payload was too big for the ESP8266 that it wouldn't have been able to parse all that data, and I needed to use something else to kind of skip through the things that I didn't want. But in a recent addition to the ArduinoJSON library, they've now introduced filters, and we'll cover that too, and it's a really good improvement. There are two main parts to the ArduinoJSON library. There's the serialization part and deserialization. Serialization is where you take data and convert it to JSON, and then deserialization is where you take JSON and convert it back to data. When you're working with APIs and the response comes back as JSON, you want to deserialize it so you can use it as variables in the rest of your project. The first thing that we need to do is actually figure out what type of response we're going to get back, because what we need to do is allocate some memory for ArduinoJSON to work with. Luckily, the ArduinoJSON library has an assistant, a tool on its website that helps with this part of it, because it can be quite confusing. The next thing that we need to do is get some sample JSON that we can use with the ArduinoJSON assistant. As I mentioned in the first video, it's much easier to figure out these APIs using a PC-based tool. We're going to use the CoinGecko API that's being used in the sample, and this is just a simple GET request, so we can just paste this into our browser and we'll get a response back. This is a really small response compared to what you probably normally see, and it is only valuable information, so that's a good thing in terms of an API that will work well with ArduinoJSON, but we'll talk about filtering out things you don't want later. So to use the assistant, you just go to the assistant page, select the board details that you need. For the mode, we're going to select deserialize, but we'll look at the deserialize and filter in a little bit. And you want to click next. On this page, you want to paste in your sample JSON. This page is probably the most important page because it tells you how much memory ArduinoJSON should allocate for that piece of JSON that we pasted in. But there's a couple of things that you'd want to be careful with. Things like numbers, it will allocate an appropriate amount of memory for it. Things like strings are a little bit more difficult because a longer string will occupy more memory, so you need to allow for that. The ArduinoJSON assistant does allow a little bit of a buffer, but if you know this sample message only had like 10 characters in it, but it could have 1,000 characters, you probably need to just go with the worst case scenario for your sample one, and then that should cover all scenarios. Similar to the strings, you also need to look out for arrays, that you really want to be dealing with the worst case scenario when you're putting it into the assistant, because if something has 10 items as opposed to 20, that will use less memory than the one with 20. Another approach you can take for allocating memory is allocate too much memory and then use the shrink to fit method to contract it to just occupy the space that it's currently using. This might sound like a really good approach, but at least for the way I use the library normally, this wouldn't make a big difference for me. The JSON parsing is normally the last thing I do in a method, so that memory is going to get freed up when I exit that method anyways, so it wouldn't really make much difference for me. The only way that's going to make a difference is if you're holding on to that JSON document. On the next page, you'll see some sample code for how to parse the data that you've just seen. A lot of the times it will recommend a static JSON buffer, but that's normally not the right choice for an ESP8266 or ESP32 project. Basically, you have two options for where you want the memory that ArduinoJSON uses to come from. If you do a static one, it will come from the stack. And the ESP8266 and ESP32 doesn't have a huge amount of stack memory, so especially for larger requests, you definitely want to avoid using that. The dynamic JSON buffer comes from heap memory, and the ESP8266 and ESP32 have a lot more of that, so that's normally the one that you want to go for. Before we look at the code for actually extracting the value, the first thing that I want to cover is that when you deserialize the JSON into that buffer we defined earlier, you actually get returned a deserialization error object. And this is really useful because you can check if you have an error doing the deserialization. So if that error object is false, you can just read your data, no problem at all. And if it's true, you can actually have an opportunity to print what the error is so you can see what went wrong. So the next thing then is getting the values out. And how you do that is you do it on the JSON document or the buffer that we created earlier. So you basically just reference the document, open up square brackets, and then reference the key name that you're trying to get out. So in this example here, it's actually a nested value that we're trying to get out. So it's in the Ethereum object, and then it's a member in that object called USD, and that gives us our value, and then the same for the Euro object as well. As for the variable types, normally just implicit casts will work fine, where you just assign the value into the type of variable that you want. But in some cases you can use manual casts too. I found that I've needed to use these when I'm working with structs. One thing you need to be really careful about when you're using char stars is this isn't the value, this is a pointer to some piece of memory that contains the value, and that piece of memory is contained in the JSON document. Let me give you an example of what I mean and how this can be a problem. So I have two methods here. One returns the message member of a piece of JSON and the other returns the num member. I define two different JSON strings, both with different values. I pass the first JSON string to the two methods, store their responses in variables, and I print them to the serial monitor and everything looks fine. I then pass the second JSON string into the two methods and I print them to the serial monitor and everything looks fine with that too. But when I print the first set of variables again, you'll see that the message1 variable does not contain what we expect. This is because the pointer is actually pointing to the dynamic JSON document inside the method, and this is getting reused. This isn't a problem for the num variable, as it's returning the actual data, not a pointer. Some people who are really paying attention might realize that the way I'm handling char stars in this example is just bad in general. I'm returning a pointer to a piece of memory that is allocated within the scope of a method. Once you leave this method, that memory could potentially be used for something else. You will need to copy that data into some other buffer that you control the memory on. Next, let's take a look at how we parse the response back from the API. So a nice thing about the ArduinoJSON library is that we can pass it the stream object, or the Wi-Fi client, and it can read the data directly from there rather than us having to copy it into a separate placeholder buffer and parsing it from that. As shown in the previous video, we've connected to the API, we've skipped over any headers that have come back, and now we're on to the response of the body, which is just going to be JSON. We can pass the stream into the deserialized JSON method that we first seen in the ArduinoJSON assistant code from earlier. Once we've that done, we can just get the values out like we've already seen. The last thing I want to cover is filtering. But seeing as this video is not sponsored and I haven't even enabled mid-roll ads, I just want to take 20 seconds to mention a couple of things. The author of ArduinoJSON has written a book about the library which he sells on his website, and it's a great way of supporting his efforts. To be honest, I think most of the details in the book are covered on the website, but I still think it was really useful. I also want to say a huge thanks to my GitHub sponsors for helping support the channel and my open source efforts. Okay, so on to filtering. A lot of the time when you're interacting with APIs, they return more data than we actually need. This normally wouldn't be a problem when you're working on a PC-based app, as you effectively have unlimited memory. but it can be a problem when you're working on microcontrollers. Luckily for us, ArduinoJSON now supports filtering, and this is where you can tell it which data points we actually care about and it will ignore all other ones. The advantage of this is it lowers the amount of memory that we need to allocate when we're defining that buffer. We can use the ArduinoJSON assistant again to help with the code for this, but what we need to provide is a JSON object in a similar format to the response we expect, but with true values for any of the properties that we actually want to parse. If you have a nested object, you can set the whole outer object to true if you want all the data, or you can specify what child object you want either. For arrays, whatever you do in the first item of the array will be applied to all the items in the array. When you are finished with the filter, you should verify it is showing the data you would expect on the filtered inputs on the right. On the code page, you will now see a filtered object that is generated to match the provided JSON filter from the previous screen. For the main document object, the same advice as earlier applies to this, that you probably want to use a dynamic one and you want to leave some wiggle room. Then the only difference is that the serialized JSON method now takes a filter object, and after that you can just parse the data exactly as we've done before. And that's it. If you have questions about the video, the best place to ask is probably actually my Discord, because it's easier for me to reply on mobile, and also there's a lot of other helpful makers there who might be able to help you out if I'm not available. I'd like to thank you all for watching. I'll see you next time. Bye bye.